In this movie we want to show you a workflow between a structural modeler and a structural engineer according to the Open BIM principle, using IFC for a change of models. In this use case we have a structural modeler using Allplan, a structural engineer using Scia Engineer. For the collaboration they use BIM Plus, where the data is shared and tasks and issues are managed in a cloud solution. The use case starts when the architectural model, the MAP model and the first version of the structural model have been uploaded to BIM Plus. So what we will do from BIM Plus, we will send the structural model through IFC to the structural engineer. Structural engineer will use Scia Engineer to create from structural model an analysis model, and he will do the structural analysis. During this calculation he will also find out that an additional wall is required to support the slabs on a certain level. The results, so the analysis model, including that extra wall and the required reinforcement, are sent to BIM Plus, the model through IFC and the required reinforcement through a special file for Allplan. In BIM Plus we will create a task for the modeler to add the wall and to detail the reinforcement based on the analysis. So the required reinforcement will go to Allplan, and in Allplan the wall will be added, should be added, and define the practical reinforcement based on theoretical reinforcement. When that has been done, the structural model through IFC, including the reinforcement, will go to BIM Plus. So the structural model will be updated, the structural model will have the additional wall, and also the reinforcement has been defined. Then in BIM Plus the next task is to check the final reinforcement in Scia Engineer to be sure that all the reinforcement what is required has also been modeled by the structural modeler. So the reinforcement through IFC will go to Scia Engineer, and in Scia Engineer the engineer will check the reinforcement. So this is the workflow which we will show you in the coming minutes. We are using different software, so what you see here now is in BIM Plus, our collaboration and communication platform in the cloud. You see that already the architectural model has been uploaded and also the MAP model is uploaded. So if I make the architectural model transparent, you see here nice the MAP model, so I can make this again non-transparent, but also the structural model has been uploaded already. So if I switch off again the architectural model, you see here the structural model which has been created in Allplan and has been uploaded into BIM Plus. So this is the situation where we are in. So if I go now to the topics in BIM Plus, you see here there is one topic addressed to me, that is structural analysis required. Yeah? There is here an attachment, so an IFC file which I can use to in Scia Engineer to create an analysis model out of it. And I can go to file and I can say import the IFC file, yeah? And I'm going to the directory where I have stored the file. It's a structural model from Allplan, IFC file. I import it, do the member recognizer, and then the IFC will be imported, and already as much as possible the elements will be transferred to analysis objects. So we see here the model. What I can do now is the foundation piles, they are not automatically transferred, so I will do that manually. I go to our BIM toolbox, I go to convert, and here you see convert solid into beam columns. That's what I'm going to do. So the foundation piles will now be transferred to beams, analysis beams, into Scia Engineer. Okay, this has been done. Now for the rest you see that there is a lot of stuff is not connected with each other, objects, so what we have to do is to connect them. For that we use alignment, and I will do that with all the objects. And what I will do is switch on some planes which I use to align the members to the right place. So I switch on these master planes, the vertical planes I switch off, and I go to the master planes, and you see here the planes which I need to do the alignment. Okay, I go here to run analysis, and automatically alignment has been done in horizontal way. I do now the same again, but I do it now for the vertical direction. So again I switch on here's some planes extended, and what I now do is I switch off the horizontal plane and I only have the vertical plane. So you see now all those vertical planes. What I do now is again run alignment, and then automatically in vertical directions the elements are aligned. What you still see is that here I have some gaps, so I go again to alignment and I say I want to do it for all entities again, and I will now switch on again those planes, and I will switch off the vertical planes, and for the horizontal planes I will only have this base plane on the 0 level I will use. I will change here the distance because the gap is more than a half a meter, so I have to use another value here, and I say run alignment, and then this gap should be closed. So now I have the analysis model ready. The next step is of course to define materials. Let's have a look to the materials. You see here the walls. So the wall, I will select all the walls automatically, and I will give it a material. We did not do that properly, so I will do that here in the CAD system. The same I will do for the slabs. So I go here, the plate. Again, I will select all the plates and give them also a good concrete material. So let's take this one, or let's go a little bit realistic value. Let's take this one. So I think that's enough. So we have the material defined. The next step is to define the structure. So what I'm going to do is to define the supports. How will I do that? I select here an inclination, select here the nodes, and all the supports have been defined. The next step is that I go to one more back to the BIM toolbox, because I have to connect the objects. Because I have aligned them, but I did not yet connect them, so I have to connect all the objects together. So let's do that. And the rest I check the structure, so that all the duplicate nodes and duplicate members will be removed automatically. You see, and now the structure is okay. Okay, I go to the loads, and the load cases, and I define an extra load case that is a variable load case. Close it now, and for that I use a surface load on 2D members, and I will go to the global coordinate system and I will say -2.5. That's my load. Okay, I go a side view of the building, and I can select these ones, the next floor, this floor, and also I will put the same load on the roof. It's maybe not that realistic, but I think it's okay for now. So I have the loads on it. The next step is that I close it again, and I do the calculation, run the analysis, linear calculation. So automatically the finite elements are generated. The mesh generator will work automatically. I don't have to take care about that. It's automatically done. And I see, okay, calculation has been finished. Now continue to the concrete. I can go to ULS, and I can now select here combinations, and I can say do the calculation of the concrete. So you see I have some errors, so let's have a look. If I switch on off the warnings and the errors here, the errors I keep. You see here, if I go to the screen, you see here I have some problems here, and it is quite logic, because if we look at the structure, it's an you can see it here, there is only a column that is very big span free. There is no wall or column or whatsoever. So what I will do is I will add a wall. So I will go here, let's have a look at the height. So I select this column, and it's this member, and you see the height of this member is 3.51. So what I'm doing now is go out of here, and I define structure. I define a 2D member, a wall, and to give the wall, I give it a height of 351. Okay. And the thickness I take 250. So let's define it, and I go here, say okay, where is the problem? I go from this node to that node. I define the wall. It's done now. Okay. If everybody's happy with it, that's another discussion, but I close it now, and what I do is go to the BIM tool. I do connect again, because I have to connect the wall with the rest of the structure automatically. It's doing now. And now it means that this wall has been connected. So what I'm doing now, I go back to the calculation, do again an analysis. It's okay. Go to concrete, member design, select again this slab I had before, hollow core, I select this, and current combination, so do the concrete design. There's still one error, but you see that the problem here is solved. There is still here some problems, but that for this use case is not that important. But you see that in this case the wall has solved this problem. So what I now will do, I will create a so-called ASF file, and that's a file with ISO lines that we can use to in Allplan to automatically create an reinforcement slab. Okay, I save it. One file has been created. So calculation has been done. So what I now will do is export this to BIM Plus. I can automatically do that here in Scia Engineer. So I type in my login. I have to choose which team I'm talking. I have multiple teams, so I take this team, my own team, and I can select the project. It's the hybrid BIM model. And I select here the correct model, analysis model, and I say upload file. So what you're doing is uploading it now, and I can continue working, and at the moment the model has been uploaded to BIM Plus. I get a message in my mailbox that the model has been uploaded, and I can continue with continue to go to BIM Plus. So the model from Scia Engineer has been uploaded. I'm now back in BIM Plus, and you see the analysis model is here visible. This is what we have created in Scia Engineer. So the next step what I'm doing, I go back to my topics. So I can go to, first of all, to the structural analysis is required. So I can go here and I can say this one has been fulfilled. So the status is solved. I save this one. That's done. The next step what I can do is to say, okay, I add a new task, and the task will be add a wall. Add wall, please. Add this wall required for structural behavior. The due date, that's have to be solved. Save it, and let's make a spot on it that you know where it is. So I add a spot, and I say it's this wall has to be added. Yep. Next thing I will do is the reinforcement. So create reinforcement. Please based on attached ASF file. This is a format from Allplan that I can use. So responsible, that is Dennis, and I make the due date, let's say it's the 9th of October. I save it, And again, what I can do now is create a spot. So I say, what are we talking? So we are talking on this slab. That's where we have to add the reinforcement. Sorry, go back. Create reinforcement. Go back to the issue. Then is mentioned I have to add a spot. So I will do that on this slab. So there the reinforcement should be added. I do an attachment, so I want to add that ASF file, that is this reinforcement. So, and in fact that's enough. So I have add the wall, this information goes to Dennis, and Dennis can now do his job. In Allplan I can start to add the wall, so I open these two and I will quickly add in Allplan the wall. Go to architecture, select the wall, thickness of the wall will be 250, and okay, let's edit. I want to have the midpoint, this point to that point, and then midpoint, this point. Okay, so the wall has been added. The next step is the reinforcement. For that I go to this floor, and what I will do, the ASF file has been imported already through the import of FAR. I already did that, so I continue now. I go to engineering, area reinforcement, automatically design. So I will give a thickness of 250 for the slab. Okay, it's asking me the area. Automatically the slab will be detected. There is an opening, so I will also define the opening, and that's from this point to that point. It's 3250, top 250. No. And then I can define some base reinforcement, and then automatically the program will, based on the ISO lines, will add extra additional reinforcement like you see here. So this is done, so I can switch on everything again in Allplan, close it. Let's have a quick look at an animation. So you see here the model is there. Yeah. If I look at this model, you see that the reinforcement has been defined. So what I can do now, I can export this now to BIM Plus again. So everything I take into account. I say login. This is my team. Okay. Structural model, upload it now. Now this model, including the reinforcement, is now updated in BIM Plus. It's done. So what I now can do, also what I can do, is export to IFC. So I can create this same file. I can export it to BIM Plus. So structural reinforcement, and say yes, okay, do it, or it exists, replace it. So now he's exporting also an IFC file, which I can immediately use. So what you see here, you see very nice that this wall has been added. If I look at the reinforcement, so I can make the building transparent, I also see that the reinforcement has been added. So what I do now, I go to the topics again, and I can say okay, add the wall. Yeah, this part has been done, so this wall has been added. So I can say the status is solved, save it, and also create reinforcement. This topic has been done. Also here I can say it's solved, save it. And now the next topic is that I will add a new one, and I will say create a topic, check reinforcement. Please check the reinforcement. Please check the reinforcement, and I will go into Herman. The optional, it has to be done before the 7th, for instance, and I say okay, save it. And I will say okay, which reinforcement have to be checked. So what I will do, I will add a spot again, and I will say it's on this slab. I will add the spot to be checked, and I can upload the IFC file including the reinforcement, structural model including reinforcement. So I will upload that file. And now Herman knows that he has to check in Scia Engineer. So I will leave now BIM Plus again, and I will go to Scia Engineer. I will upload, so I go here and I say upload the IFC file, and it is this IFC file. He will compare, the engineer will have a look what has been changed. Of course I have changed some materials in the analysis model, so we will I will import the reinforcement, I accept it. And I say close it, and then you see I have the reinforcement in Scia Engineer. So what I can do now in Scia Engineer, I can first I do allocation, so I will select the bar here, the reinforcement bar. If I have one, I can select them all. So I can say all the material, all the reinforcement bars. They are selected. I can allocate, that means that the bars are assigned to a specific analysis object. That's the next step I have to do. He's doing that automatically. Okay. I do a recalculation. Now I will check if the reinforcement in that slab is still enough. Okay. So I go to concrete, ULS, and will select this slab, current, and what I will do is I go here and I will have a look, required reinforcement. I will look at additional reinforcement. Is additional reinforcement required, yes or no? So I do a refresh, and he's now calculating the whole slab again. And you see it's all blue, it means zero reinforcement is needed. We are now at the end of this movie, so let us summarize the benefits of this way of working. An important benefit is that everybody can use the software that fits the best to their needs. Nobody is forced to use a specific software, so use the tools that fits the best to your work, and through the open interfaces like IFC, the models can be exchanged. Responsibilities are defined where they belong. The engineer is responsible for the analysis model, so he should be able to create this model himself. He is doing that in, for instance, Scia Engineer, using the structural model as base. The reinforcement detailing is done by the structural modeler in, for instance, Allplan. It is his responsibility, of course making optimal use of the analysis results.
Required changes defined by the engineer are not automatically updated in the structural model. This should be done by the responsible of that model, the structural modeler. Changes are managed by using a central place. In this case, BIM Plus, a cloud-based collaboration and communication platform, is used, where all the topics, tasks and issues are managed in a proper way, and wherever you are on the world, you always have access to this platform and you can see what are the next tasks to be done, are the tasks executed, etc. So you are fully aware of the actual situation. Thank you for your attention.